Okay, welcome back, everybody. Let's continue with our class. So, like I said previously, I have a movement of a body from X. A body is thrown upward. So I throw a body vertically upward from X. It goes to Z, where it stops for a while before it comes back towards Y. So this is the upward movement, and this is the downward movement. So I've already talked about the fact that gravity J is acting vertically downwards always, which is 9.8 meters per second squared, or sometimes 10 meters per second squared, which is an approximation of this. The upward motion becomes positive, positive, and then the downward motion becomes negative, negative. Now, I would like to derive certain equations from this diagram. We would like to derive certain equations from this diagram. The first equation that we want to talk about is the maximum height reached, that is x. Now consider this diagram again. If the body moves from here to this point and comes down, the maximum height reached is x to z. That becomes the maximum height reached, that is from x to z. Okay, so before we can derive our equation, we can say that at maximum height, the final velocity is equal to 0, because initially when you throw the object, you give it a velocity, but when it moves and it gets to this point, it halts for a while before it comes down. Therefore, that is the final velocity, and therefore the final velocity is equal to what? 0. And since it is an upward movement and it's moving against gravity, then we are going to use the motion for upward movement. So upward movement. So this one is upward movement. This is upward movement, and then this is downward. This is downward motion. Okay, so since it is moving upward, it is moving against gravity. So if we want distance s, the suitable or the best equation that we can use is either this or this. So let us come and look at this equation. We can say from equation 3, v squared is equal to u squared minus 2js, but v is equal to 0, so it implies that 0 squared is equal to u squared minus 2js. We can say that 2js is equal to u squared. Therefore, s is equal to u squared all over 2j. So this is how you can be able to calculate the maximum height reached. The next thing that we can talk about, or I want us to try and find, is what we call the time taken to reach the maximum height. The time taken to reach maximum height. Let's call that small t. The time taken to reach the maximum height. In deriving that equation too, we can also come back. It is also an upward motion, so it's a distance from here up to here. Okay, so we can say from equation 1, v is equal to u minus gt, but the v is equal to 0, implying that 0 is equal to u minus gt. Therefore, u is equal to gt. So t is equal to u all over g. This is the equation for the time taken to reach the maximum height. Then one thing that we can talk about is also time of flight. Time of flight. Now, those of us that are used to boarding, or those of you that are used to boarding planes or moving from directions to different directions or from situations to situations, you realize that the time of flight is the time that you begin a journey and end a journey. So when we come back to our diagram this way, the time of flight, if you start from here, move to here and come here, then the time of flight is the distance from x to y but through z. So this whole thing is the time of flight. And in most cases, the time from x to y is equal to the time from y to z, or from z to y. So it implies that the time of flight t is equal to t1 plus t2. So where t1 is the upward movement and t2 is the downward movement. So t becomes equal to u over j plus u over j. So t becomes equal to 2u all over j. Therefore, the time of flight becomes equal to 2u all over what? J. So that is the equation that we have for the time of flight. You can see from the board that we have three equations that are very significant to us. Let us take note of those three equations. Then in some situations also, you may have to come and calculate for other things. Let us look at this example. Assuming I have, let's say, a wall or a brick wall here, and the distance from here to here is, let me call this x, and an object is thrown to cover this distance. So an object is thrown from a point here to another point here to another point here. Okay, so for such a situation, if you want to calculate the total distance moved by the object, if you want to calculate the total distance moved by the object, then you are going to have the s, which is equal to u squared all over 2j, plus the x, where this x becomes the distance representing x. Okay, so you can calculate from here to here, and then you add this one to it. Okay, so this here, x here, is indicating the distance from the ground to where the object is thrown from. Okay, so the whole distance, or the total distance, becomes s is equal to u squared all over 2j plus x. Let us just try a few examples and then see. Okay, so looking at the question on the board, we have a body is thrown vertically upward with a velocity of 30 meters per second. Find A, its velocity 2 seconds later, B, the time of flight, and then C, the maximum height reached. You have been given J to be this. So in our solution, the first thing, let's write what has been given to us. We have been given an initial velocity of 30 meters per second. Okay, and then A, we are to find its velocity 2 seconds later. We know that V is equal to U plus what? AC. Now, once the body is being thrown vertically upward, then we know that the body is moving against gravity. So therefore, this equation becomes V is equal to U minus GT. The initial velocity is 30, and then the time for the A question, time t was 2 seconds. So you have 30 minus 10 multiplying 2. So V becomes 30 minus 20, which is equal to 10 meters per second. This is how you go about the A part of the question. Then the B part of the question, you have to calculate the time of flight. We know t is equal to 2u all over j. So this becomes 2 multiplying u is 30, so 30 all over 10. This goes here, this goes here. So you have 6 seconds. So this is what you are going to get for the time of flight. The next question, you have to calculate the maximum height reached. The maximum height reached. That is the C aspect of the question. You have to calculate the maximum height reached. We know the equation for the maximum height reached, S is equal to U squared all over 2J. Okay, so we have S to be equal to 30 squared. So let me write 30 times 30 all over 2 times what? 10. So X becomes, this is 900 all over 21, 1 here. So S becomes 90 over 2, which is equal to 45 meters. So you are going to have this to be 45 meters. One thing that you have to know is that you should be able to keep most of the equations off head so that you can be able to calculate and solve your questions properly. Okay, we'll move on to another question and see how that one also goes. Okay, so let's focus on the next question. We have a ball is shot upward from the ground and back in 4 seconds. Calculate the maximum height reached by the body drawing the journey, or by the ball drawing the journey. Good. So in our solution, let us just quickly draw a diagram. So let's say this is the ball shot from the ground to this point. Okay, so the time of flight is 4 seconds. It implies that t is equal to 4 over 2, which is 2 seconds. That is the first thing that you should know from the question. Then the maximum height reached, S is equal to U squared all over 2J. But the question did not give us U. It gave us J to be 10 meters per second. So from the first equation, also from Newton's first equation, we know that V is equal to U plus 80. But here we're talking about upward motion. So for the upward motion, we can say that v is equal to u minus gt. But at this point, you know v is equal to 0. Therefore, 0 is equal to u minus gt. So u becomes gt, which is equal to 10 times 2, which is 20 meters per second. This is 20 meters per second. This is your u. Okay, so it implies that s is equal to 20 squared all over 2 times 10. This is 400 all over 20. Here 1, here 1, here 20. So you have 20 meters. And therefore, your distance or the total distance covered is 20 meters. Thank you very much. I think I'll end this one here and we'll continue very soon. Thank you for subscribing. Please follow us. We are going to come up with a lot of questions and also new topics. Okay, so subscribe to our channel. Thank you. Have a good day.